Hello all. Uh, Welcome to session 5 and 6. Just wait for 5 minutes. If anyone joins, we'll wait. After 5 minutes, we'll continue the session. Hello all. Welcome to session 5 and 6 of Langchain series. So let's recap once what we have done till now. So in the session 1 and session 2, we have discussed multiple components in Langchain. So we have discussed how to use, how to interact with LLMs, and also we have discussed how to interact with embedding models, both proprietary as well open source models. Right. Uh, if you see week 2, we have completely discussed what are essential for a RAG system to build a RAG system. We have seen document loaders. We have discussed about uh, text splitters. We have discussed about vector stores. we have discussed about embedding models, and also we have discussed about retrievers. So finally, whatever needed to build a rack system, we have discussed, and also we have built a simple rack system in our last session as well. Right. So today we are going to discuss in session 5 and 6, we are going to discuss another components of Langchain, which are very essential components in Langchain. The first one is what is a memory, and what types of memory is there, and what is the use of a memory in building AI agents using Langchain. After that, we will discuss what is a multimodality, and we will see a simple example. We'll upload an image and ask simple questions, what is present in the image, right? We will code that and we'll see what is multimodality in real, right? And then we will discuss about runnables and chains in Langchain. So runnables and chains are very essentials in building any workflows in the Langchain. So in runnables, especially we are going to discuss five types of runnables which are mostly used in Langchain. First one is runnable sequence, then runnable parallel, then we will see runnable pass through, runnable lambda, and runnable branch. I know currently we don't know what are runnables and what are these things. Uh, when this topic comes, we will discuss in detail what are runnables and what are this runnable sequence, runnable parallel, runnable branch, all these things. We will get practical knowledge on how to implement these things and how to make uh, complex chains in Langchain using these runnables and chains. So once these runnables are over, then we will jump into tools and as well as tool calling, right? So we are slowly moving towards building agents. Till now, if you see, we haven't discussed about anything related agents. We are only discussing about how to build workflows in Langchain, right? We didn't see the real power of agent till now. So uh, with the concepts of tools and tool calling, then we will slowly introduce what are agents, how these agents uses tools and tool calling in real time. And also we'll build a couple of tools, a simple calculator tool and as well as a weather tool. I'll code you and I'll show you in real time how to define these tools, and also how to call these tools manually, and also I'll show you how agents initiate these tool calls and etc. Right. So I hope this session 5 and 6 agenda is clear. With that, we will start with memory first. Right. All right, guys. So what is memory in Langchain? Uh, let's say uh, memory is very essential component in Langchain. Our memory is essential for building any workflows or any agents using Langchain. Why it is essential? Because if you don't implement a memory component in your workflows or in your agent or workflows cannot get what previous interaction happened with that particular user. It means, see, generally in session 1 or session 2, I think I have already shown you one practical example. If you these you know if you are interacting with LLMs through API, these APIs are stateless calls. It means there will be no relation between your first message call and your second message call. Let's say you are building one agent for the uh, e-commerce chatbot e-commerce chatbot, right? One user comes and he is asking some doubt about his order, right? Let's say his first question will be, uh, uh, I have ordered something on so and so date, till now I haven't received my order. So this is the user's first question, and you haven't implemented any memory component in your uh, in your workflow or in your agent flow, right? So what will happen? Your agent will ask the user to provide the order ID to process further, right? So this with this first interaction is over, right? Then in the second interaction, what user will do? User will simply enter his order ID and then will hit our agent, right? Now, what user thinks, I have already interacted with the agent earlier with all my details. So this time I can only enter order ID instead of repeating a full previous message. But the problem is this LLM call won't remember the previous interaction which was happened with the user. Then what LLM thinks that user entered some number, right? Generally order ID will be in number or mix of characters and numbers, right? So LLM will not identify that he is asking about order, then it will reply something else. So this is the real world problem where memory is useful. So let's implement this practically so that you will get the clear idea what I am talking about, right? So let's go. Let's open our Visual Studio first. All right. So I'm going to create a new folder, and I'll call it as a memory folder. Then I'm creating one new file. Uh, I will say that without underscore memory dot ipython ipyn. All right. So let me take a first code node. Before that, let me activate my environment. Uh, Give me a moment. Yes. So it has been successfully activated now. So from the day one, we are already writing this code. I think this code, let me copy paste because we know this code already. So what I'm doing here, I am importing chart OpenAI from Langchain underscore OpenAI library, and then I'm importing prompt template from Langchain underscore core dot prompts. Then also I'm importing load.env from .env library. Then I'm calling load.env class, which will load our API keys which are present. Just a second, guys. Let me close all these things, which are present in our env file, right? You can see our env file. This is our env file. I have OpenAI API key, Google API key, Hugging Face, and as well as Pinecone API key. Anyway, for today we are not going to use any of these APIs. Still I have kept it in my environment file. We are mostly going to use OpenAI API key, right? So once this is done, this will successfully load all our keys into our environment, right? Once that is done, what I have done, I have created chart openai object and storing that reference into LLM, right? This is we are doing from day one. And then I have taken prompt template as well and assigned to prompt variable. Now, in the prompt template, what I have mentioned, you are helpful assistant, answer the user queries, and user query I am passing over here. So this is going to be my input variable. That's why I have declared input variables text as my input variable. Then what I have done, I have taken one while loop and I am asking user input, and then I'm asking, I'm making, you know, I'm calling prompt using format method so that it will fill a proper prompt with the user input. In the text, I am passing user input. Let's say user said hi. Then what will happen? Our complete prompt template will become you are a helpful assistant, answer the user queries, and user said hi, right? So this is going to be our complete prompt. Then response, I am invoking the LLM by passing our prompt, and then LLM will give the response. That response I am printing as AI's response, right? So extra what I have done, I have added extra human and extra AI manually to not to confuse what question is asking by the user and what reply you are getting from the AI, right? So this is the simple program. let me run it and then start interacting with our LLM. Remember, I am not using any component, any memory component over here, so that you can understand the real problem. Then we will see how to overcome this problem, right? So let me run it quickly. Let me select my environment and then run it. All right, it started running. All right, guys. So you can see that it is asking for user input, right? So let me ask let me say that I am Naresh from Euron. So this is the human question is I am Naresh, right? Just a minute. I am not printing this. Let me print user input as well. Print user input so that we will not be having any confusion who is talking what. So let me stop this and then rerun. So let me rerun it. Right. So it is asking the first question. Then I'll tell to LLM that I am Naresh from Euron. Right. So this is the user query. For some reason human it is not attached, it is fine. So you can understand, right? This is the user query and this is the AI's answer. What is the AI's answer? Hello Naresh from Euron, how can I assist you today? Now generally what do you think? If I ask to LLM who am I, it should answer my question, right? Because I have already informed that I am Naresh and I am from Euron. But what LLM does, let's see. Let me ask who am I to the LLM. Now, who am I is the user query and LLM processed and then it is printing AI's response. If you observe AI's response, you can see that I am sorry, but I am not able to determine who you are as I am an AI assistant and do not have access to personal information. Right. So, with these interactions, we can conclude that our LLM or our workflow or our agents will not remember our past conversations. Isn't it bad? Just now I said I am Naresh, and next interaction I am asking who am I, and my LLM is not able to respond me back saying that you are Naresh. Right? It failed to say that it failed to identify who am I. So this is the real problem. If you don't use memory component in building any workflows, this is the problem you are going to face. And now we will going to solve this problem. We will assign a memory component and then we will interact with our LLM, and this time we will see system will identify me or not. So before that let me take you to my PDF file and explain, because there is a lot of confusion about these memory components in Langchain. Earlier they were supporting you know several things they were supporting. I think now they have deprecated in version from 0.3.0 onwards. So current LLM version, if you are using current LLM version, and you main most of the most of the memory classes are deprecated. So learning those deprecated classes will not help us out, because Langchain itself deprecated them, and it is not advised to use these deprecated classes going further. So for that, that is the reason I am not discussing about whatever deprecated libraries. You can see over here I have given all those things which are deprecated. Let me take a moment and see what it is. Just a minute, guys. Yeah. So you can see over here. In older Langchain versions, there are memory classes like conversation buffer memory, conversation buffer window memory, etc. These are deprecated in recent versions. So if you see anywhere in YouTube or anywhere, most of the people will be discussing about these things, but unfortunately, these memory classes are deprecated. Learning these deprecated classes now will make no sense. So that's why we are not going to discuss about conversation buffer memory or conversation buffer window memory and all deprecated classes. Instead, we are going to instead what we will do, we are going to discuss about in memory chart message history, right? So Langchain introduced a separate class called in memory chart message history. Before discussing that, let me clarify you. Generally memory will be two types. One is temporary memory, and then a second is permanent memory. So what is temporary memory and what is permanent memory? So generally, you can define that a temporary memory is a kind of memory when you stop your agent or when you stop your program, all your memory will be erased. So this is called a temporary memory. It means generally these kind of things will be stored in your RAM. When you restart your system or when you restart your program, you know, automatically all this memory will be erased. This kind of memory will be called as a temporary memory. And second type of memory is permanent memory, where you store these interactions in persistent databases like it might be anything. It might be a PostgreSQL, it might be MongoDB, it might be a file system, uh, where when you restart your program or when you restart your system using these databases or using file system, you can load uh, those interactions back into your program. It means it will store, you know, permanently either in file system or either some external databases, right? So this is called a permanent memory, and where you store inside your RAM, right, or inside your where inside a variable. These kind of memories are called temporary memories, right? I hope you can identify what is temporary memory and what is permanent memory. So not only databases like SQL, NoSQL base, even vector database, you can store these interactions, right? So this is also called a persistence storage. All right. So now let's I hope we have cleared what is memory, what is temporary memory, and what is permanent memory, and also we have cleared what classes are deprecated in a Langchain from 0.3 onwards. So studying those classes will not make any sense. Instead, we have to use chart message history plus runnables, right? So our for robust and persistent memory, Langchain is slowly moving its persistence into a Langgraph, framework. Even Langgraph is also developed by the same team which are developed Langchain. So that's why they are slowly moving their persistence things into Langgraph. But when we are discussing about Langgraph, we will discuss in detail about this memory persistent memory in Langgraph. But right now we will discuss in memory class, right. Let's go and do the let's go and program first, and then we will identify what was happened in earlier program and what how we are going to solve that problem in current program, right? So for that, what I'll do, let me quickly end this. So I hope this problem is cleared, right? Let me end this, and I'm going to take a new file. So let me take a new file, and this file I'll give with underscore memory dot ipynb. All right. So let me take a code node and let me start importing required things. So first couple of imports you already know, which is chart OpenAI and then prompt template Chart OpenAI and 22 loop. Give me a moment, guys. Yeah. So same imports, whatever we have seen in the earlier program, I have imported these two, and let me import even a load.env as well, because these are not going to change, right? So I have imported chart OpenAI, I have imported prompt template, and also I have imported load.env from .env. Now for the memory, we have to import a new component which is exist inside langchain underscore core dot chart history. So let me import that from langchain underscore core. So you can see over here langchain underscore core dot chart history. You can see that how many class it supports agents, catches, callbacks, chart history, and chart loaders, right? So let me take chart history. From here I need to import in memory chart message history, right? So in this class we are going to store all our charts. All right, so let me declare this class first. I think till here everything is fine. So these imports we are seeing regularly from the day one. The new import I have taken today is in memory chart message history class. In this class it comes up with some couple of methods. Using that methods we are going to save and retrieve the our chart history, right? So let me declare my memory first. Memory, I'm taking a new variable called memory, where I'm going to declare my in memory chart message history class, right? So if you hover it, you can see that it accepts a messages, a list of a base messages, right? All right, so after that, what we need to do, we need to interact with the llm. For that we need prompt, and as well as we need to declare one llm variable. So let me declare one llm quickly. Llm, this I'm taking from chart OpenAI class. You can pass model, which model you want, and also you can pass the temperature, right? So let me take a 3.5 turbo model, and temperature I'm keeping a 0. This is completely optional. If you want to avoid, you can avoid, right? Then I'm going to declare my prompt little bit different than earlier. Why? Because uh, I am injecting the previous messages into my prompt. I have to inject, right? Then only LLM knows about what was the what this user has been discussed in previous message, right? So for that, what I'm taking a prompt template class. In that it accepts couple of things, which is template and as well as input variables. So this time my prompt, I'm giving a different prompt saying that answer the following question, and this question will be entered by the user, right? And then I am attaching previous conversation whatever I have in history variable. So basic funda is we are going to store whatever interactions happened between a human and AI. Those interactions we are going to store in memory chart message history, and then we will load that and will pass into history variable. So now our LLM will have the context of previous conversations. Now, current question it can easily answer by referring previous conversations, right? I hope it is clear. All right. So if it is clear, then same whatever we have done earlier, I'm taking same thing. I'm taking a new while loop. Let me add it over here. All right. So you can see this, guys. I have added a new while loop where I am expecting user input. From input, I am assigning this input as a human. And then what I am doing, if you see my memory, now my memory will be accepting a couple of messages. One is add use, couple of methods. One is add user message. In add user message, what we need to do, all user messages will be stored, right? So I have taken the memory variable, and then this memory variable I am calling add user message. In that input I am passing user input. So it means what will happen, whenever user enters something, that will go to user input, and that user input we are assigning to memory using add user message method. Got it, guys? Then same thing. We are constructing the prompt. I have already have a prompt variable, and then I am calling format method, which requires couple of variables. First variable is question, and second variable is history. Right. So what I am doing here, question, I'm as it is I am passing user input. All right. So in history, I am passing memory dot messages. So if you see my memory, and memory, currently I don't have anything currently I don't have any past interactions, right? So in that case, what will happen, in my memory it will be having a empty list of messages. So in first interaction, my question I'm going to pass inside question variable. In history, it will be a empty list, right? All right. So once that is done, then I'm trying to interact with my LLM using invoke method and passing my prompt, whatever I constructed in the previous step. Now, once this is done, LLM will give the output. That output, what I am doing, I am storing it into a variable called a response. Correct. So this is the variable called response, and LLM, whatever LLM gives the response, that is going to store it in a response variable. Now, so we clearly now know that this is AI's message. So now what I have to do, I have taking same memory variable, and then this time I am using different method called add AI message. So earlier I have used add user message because this is user message, and this time I am going to add AI's message. That's why I have taken add AI message method, and then response dot content, whatever inside response we know that there will be several keys, right? All metadata will be there in the response. It will contain completion tokens, input tokens, output tokens, which model we have used, right? So we have seen in earlier sessions. So response contains so much metadata. So we are avoiding all that metadata, and then we are simply taking content out and then storing it into a memory. Correct. Now I am printing that what AI is responded as well. Then I am taking a line gap, and then I am printing conversations so far. So far, whatever conversations happened between human and human and AI. So I'm going through memory dot messages. Initially, if it is initially it will be empty list. At that time, we don't see any prints, but one interaction happened. Then inside memory dot messages will be having a user message as well as will be having AI message. So you can see over here, I am printing message dot type. It gives either it is user message or AI message, and as well as message dot content, which gives in the content user query, and as well as you know AI's response. So this is the program about. Let me run it and give the same interactions whatever we have done earlier, and see how this memory component is going to solve that particular problem. Right. So let me save and run it. So let me run this program. I have to select my Python environment. So same environment I am selecting. Now it is executing. Yeah. So now it started asking a human message. So what we have given in the earlier, I told to LM that I am Naresh and from Euron. I'm Naresh and I'm from Euron. Right. So let me hit enter. Now you can see here downside AI's response is hello Naresh. from Euron. How can I assist you today? Conversation so far. So this for loop is printing human in the starting. It is human told to LLM that I am Naresh and from Euron. Then AI replied, "Hello Naresh from Euron. How can I assist you today?" So this was the our previous conversation, right? Now if I ask the second question, who am I? Since this previous history, I am assigning to history variable, and this history variable will be act as a context to the LLM, so that our previous interaction is also we are sending to the LLM. Now, LLM will be having new user query. Also, LLM will be having earlier interaction, right? So that now if I ask who am I, LLM will answer my question and it will say that you are Naresh. So let us see that, and I will ask who am I. Now you can see human asked, you can see that hello Naresh from Euron. How can I assist you today? If you see the conversations so far, uh, guys, so something wrong in the conversation, but AI response you can see that hello Naresh from Euron. How can I assist you today? This is the AI response. Give me a moment. Who am I? So for some reason my history is not injecting into my prompt. Just a moment, guys. So in first turn, it has successfully inserted. I am Naresh from Euron and hello Naresh from Euron. How can I assist you today? I'm sorry, I do not have enough information to determine who you are. Should not be like this. Let me do one thing. Let me quickly escape it. One second, guys. Yeah. I don't know what was the problem. Let me do one thing. So I have cleared and rerunning the program and see. Let me run it. And the human is asking, I am Naresh from Euron company, right? So let me hit enter. All right. So hello Naresh from Euron company. How can I assist you today? All right. So first message is working fine. Let me ask second question. Who am I? All right. So you can see that second conversation so far. You can see that you are Naresh from Euron company. So for some reason, it is zigzagging. I don't know the reason. So let me do one thing, guys. Let me stop it completely and then show you one more time. Let me stop it. So instead, I can do one thing. Let me let me create a new file and then take it as a .py instead of ipynb. For some reason, this extension is not working. Let me do one thing with underscore memory1 dot py, right? So let me add it over here. Now it is a Python file so that I can execute from the command line. So let me save it. So I am not printing users message. Let me print user message as well. So let me add it human and then user input. I'm going to print. All right, guys. All right. So let me save it and then run this program. So it is inside a memory folder. So I need to run as a Python memory inside memory with underscore memory one dot py, right? So let me execute it. I hope it is visible. Yeah. All right. So it is asking human message. So let me enter. I am all right, guys. So there is some problem. So please allow me a moment. Let me restart Visual Studio Code and see, because as soon as I type something, it is disappearing upside. I don't know. So there is some problem. So give me a moment. I will quickly restart and then show you this. All right. So file, exit. Let me open again. All right. So let me do one thing. Let me quickly activate my environment. So, all right. So in my environment is successfully activated, and let me run the program again. Right. No, guys. Setup has detected the setup currently running. I don't know what was the problem. Uh, Cancel it. So let me open again. It was not terminated properly earlier, it seems. All right. So let me activate it. My virtual environment I activated, and then I'm going to run my program again. Hopefully this time it works. Just a moment. All right. So it is asking a human message first. Let me enter same message. I am Naresh from Euron company. Right. Let me hit enter. So this is the human message I am printing again. That's why it is printed. And then AI replied that, "Hello Naresh from Euron company. How can I assist you today?" Now this is the conversation happened so far, right? So now it is asking me a second message. Now let me ask, who am I? And hit enter. So now you can see that AI's reply is, who am I? AI's reply is, you are Naresh from Euron company. And conversations so far, you can also see that the first conversation was, I am Naresh from Euron company. And AI replied this, hello Naresh from Euron company, how can I assist you today? And user asked again second question, who am I? And AI replied successfully, you are Naresh from Euron company. Now, let me ask the third question, and let's say that, uh, where do I work? Where do I work? Now, so you can see it is clearly able to identify that where do I work was my question, and it is identified you work at Euron company, right? So, you can see that uh, by using this in memory chart history class, in memory chart message history class, we can able to successfully store our user and AI conversations, and as well as we are retrieving them, and then we are sending back to the LLM as a context. Now our LLM has the context who is nourished, that's why it is able to answer my questions, right? So if you want to see what methods are available inside this class, you just hover it, press control and then click over here. So it will come to you in memory chart message history class. So you can see that the description of this: in memory incompletion of chart message history stores messages in a memory list, right? Now there is a method called messages. So whenever you are calling this messages method with respect to in memory chart message history class object, then it will give you all a list of messages, right? So also it has add message method. So it has add user message as well, add AI message also, right? So you can go through this class so that you will get what see this add AI message is over here, and as well as add user message over here. So you can go through this class so that you will get the better idea how to implement this chart, in memory chart message history. So I hope whatever the problem we have faced in the program one, we have successfully solved, right? Now, so if user is keep on asking something to the AI, right? And this interaction length over the time, this interaction length is going to be huge and huge, right? So we all know that LLMs has a limited context window. If it is a small language model, it supports some kind of context window. If it is proprietary models, they also based on the proprietary model you use, it may support 128k tokens as a context window length. Or so after what will happen once your message history or past message history is going beyond to that context length, then your LLM will not process your will not process your query, obviously, right? Because you are exceeding the context length. So this is the basic problem of in-memory chart message history, right? To avoid this, how we can avoid this? There are several ways to avoid it, right? There are several ways to avoid it. One method is to keep only a last five or last 10 messages in the in-memory chart message history. Like what I am telling. So whenever you are retrieving here, you can see that whenever you are making a prompt, you are getting history memory dot messages. You can write a logic something that it will only get past five interactions, right? Or you can write a logic get past 10 interactions, instead of sending, let's say user talked with you 1,000 messages, 2,000 messages. You cannot keep everything into your history and send to LLM. The first problem is you are sending a huge data, so latency issues will come. Second problem is when you are exceeding the context length, your LLM cannot process your user query. So these are a couple of problems you will face when history is keep on increasing. So for that, one strategy is keep last n messages. It might be 5, it might be 10, it might be 15, right? That number you can decide and you implement your own logic, and then send it in the history only past five messages. So this is one kind of approach. In this approach again there is a problem. In this approach again there is a problem, right? So let's say you are passing last five interactions and user was referring uh, you know uh, the message which he chart about, which is exist in 10 messages ago, or 6 messages ago, then again your LLM face the same problem, right? So in that case what you have to do, uh, at certain period, let's say your history become 50 or 100, then you can make a LLM call, and then keep summarization version of the history into your memory. Then instead of passing a list of messages, you can simply pass summary of these messages, so that you can reduce your context, and also you can you know you can fit more context aware message as a history. So these are the couple of types you can do, or there are several ways, right? There are several ways to solve. You just need to uh, work on it and then start implementing, right? So this is how we have to implement with memory, uh, using in memory chart message history class, right? I hope it is clear. If it is clear, then we will jump into our next topic, right? So what was our next topic? All right. So we have discussed what is memory and types of memory. We have discussed temporary and as well as permanent. And also we have discussed what is the use of memory. We have seen a real world problem, and also we have solved that problem using in memory chart history message class, right? So if you see this program, most of the times the problem in the second approach is most of the things you are doing manually. It means you are inserting every message manually, right? You are using every message manually. Instead, what you can do is you can use a special class called a runnable with message history, runnable with message history. So I think we can discuss it now. Later when we are discussing about runnables, you can get more clarity on how to implement this runnables. But for now, I will write a program, and then I will try to explain. If in case you don't understand what is this runnable with message history, no problem, because when we are going to discuss runnables in detail, at that time you will get the clear idea, right? Let me do that program as well. Let me take a new file, and this file name I am going to name it as a with underscore runnable underscore memory dot py. All right, guys. So let us import required imports first. Let me start importing whatever required things. All right. So if you see, there are a couple of more imports I am doing when compared to earlier imports, right? So let me explain what are those extra imports and why do we need those extra imports first, and then we will go further into the program. So there is no doubt about chart OpenAI, because we are going to use chart OpenAI class for interacting with LLM. So that's why we have made this import. And then we already know Langchain underscore core messages. We are importing human message and as well as AI message. This also, I hope this is also, there is no confusion, because we already seen what is human message, what is AI message, and also what is a system a message, right? And then from prompts, I'm going to import chart prompt template, message placeholder. If you remember, when we are discussing about a prompt components, we have used message placeholder to keep the history of previous messages. So in the session 2, we have discussed about chart prompt template as well as a message placeholder also. And then there is a string output parser. When we are discussing about a rack based system, we have discussed about output parsers. Several output parsers are available. One is string output parser, right? Uh, and pedantic output parser. Several output parsers we have discussed, right? So I am just imported a string output parser from output parser to extract result dot content from the LLM call, right? So the only extra things we are importing here from chart history, I'm going to import base chart message history class and in memory chart message history. In memory chart message history we have already seen. Then we are extra import is base chart message history, and we'll see why we are importing these things. And then from runnables dot history, you remember this runnables. We are going to discuss again and again about these runnables. So going forward, you will get what are these runnables and why do we need runnables. At that time, we will discuss in detail. From the history component, we have library. We have imported a runnable with message history. So basically, what we are going to solve from the previous program. So first program, there is a problem of memory, right? In the second program, we have solved it using in-memory chart message history. But the problem is manually we are taking human query, and we are adding it, right? And also manually we are taking AIS response and we are adding it into the memory. So everything we are doing manually. To avoid that manual effort, we are going to learn a new thing which is called a runnable with message history. So this will take care of adding and this will be take care of adding your AI messages and as well as your human messages automatically, right? So that we'll see how we are how it is going to do that. uh, all right. So after this, I'm going to declare one variable called history store. So where when I want to send previous conversations to the LLM, so that I can import this history store and then I can send it in my prompt, right? So also I'm declaring one method called get history. What I'm doing here, I am passing session id as an input to get history method. And then if that session id is not there, if that session id is not there, I am going to send an empty list. If that is there, then I am going to send that complete list, whichever whatever the previous interactions happened inside that session id. I am going to send all uh, all history. I am returning through this get history function, right? All right. So now I am going to implement a chart prompt template. Earlier we have declared prompt template. Now I am taking a chart prompt template. So what is the advantage of chart prompt template? Right, you can use message placeholder where you can pass all your history over there, right? So and also I have taken human message prompt template, and I am passing one input variable that will see what input whatever the question user asks, that will go as a input to the prompt, right? Now let me declare couple of variables also. One is LLM chart. From chart OpenAI class, I'm declaring LLM variable, and from string output parser we are declaring parser as well. Right, now here is the thing. Now what I will do, I will declare a new runnable class which is a runnable with message history. Runnable with message history, and I'm storing it in chart with a memory variable. Chart with memory variable. I have taken a new class called runnable with message history. Don't worry about this runnable with message history and what we are doing here. We will discuss in detail about runnables in the upcoming session. So no need to worry about it. Now simply understand what we are doing here. We are passing one simple chain. So we have discussed about LC Langchain expression language. At that time we have discussed about how to form a simple chains. So the first what it will do, whenever you are invoking this chart with memory, right? Whenever you are invoking chart with memory, it will automatically make a prompt, and whatever the output of prompt will go to input to the LLM, and LLM will give the output. That output will go to parser as an input, and parser extract the content from the LLM's output, and then uh, will back return back to chart with memory, right? So this is how it works now. And also I have declared couple of things. One is get session history. So I have assigned get history function, whatever the function I have defined over here, right? So whenever I pass some session ID, then this is the responsible to give a particular messages under that session, and that will store into get session history. Then we have a couple of variables, input and history. Those two variables I have declared over here, right? So once this is done, then I'm going to write my while a loop. Now, don't worry about this runnable with message history, how it works. We will see in details when runnables we are discussing. Right now, I have taken a session ID and I have hard coded it as a session underscore of one. Right now, I have taken a while loop. Inside while loop, what I am doing, user input I am asking, and then result I am considering it as a AI message. And you can see over here chart with memory, which is basically an object derived from runnable with message history, and then I am going to invoke, right? In the invocation, we need a couple of things. Input, I am passing user input, whatever user enters as a query, that will go inside input. Then in config, we are passing session ID so that these messages will store into that particular session ID. For our reference, I am printing AI output. So that's it. So this is how the program. Now we are going to run this. So if you observe carefully, we are not adding any message. Earlier we are using add human message, add AI message. So many things we are doing, right? We avoided completely that manually adding, human and AI message. So now what is having a Langchain framework itself taking care of that adding, you know, maintaining our memories properly, right? All right. So now let me run this program. Let me kill it first. Let me kill it and clear my screen. All right. So now how I have to run, use Python, and then it is exist inside memory folder. So memory with underscore runnable underscore memory dot py is my Python file name, right? So let me save this file before execution and execute. All right. So my first question, I'm going to add a same thing. Otherwise, you will get confusion. So I am Naresh from Euron company or institute, whatever it is. Uh, yeah, guys. So you can see that there is some warning. Ignore it for now. This is just a warning. Uh, Let me see how to solve that problem. But you can see that uh, hello Naresh, nice to meet you. How can I assist you today? So this is what AI replied to us. Now I will ask, who am I? Now you can see that you are Naresh, a representative from Euron company. How can I assist you today, Naresh? So it has successfully storing our previous conversation, right? Now let me ask, where do I work? So a response, you can see you work at Euron company. Is there anything specific you would like to know or discuss about your work at Euron company? Now I will say I am from India. I am from India. So that's great to know, Naresh. Is there anything specific you would like to discuss? Now I will ask, who is my prime minister? Right. See, I am not asking who is prime minister of India. I am asking who is my prime minister. Right. So since this particular conversation going to the LLM as a context, so LLM now understands that, okay, so he is Naresh. He's basically works in Euron, and then he is from India. Now, if I ask a question, so who is my prime minister, and it will refer my previous context, and it will find out that, okay, Naresh is from India, and if he is asking about prime minister, he must be asking about India's prime minister, so that I have to reply according to that. Now let me ask, who is uh, my prime minister. So now if you see that I'm not mentioning India anywhere, but in my previous conversation already I have mentioned that I am from India, so that I am expecting it gives correct answer. All right. So now you can see the AI's response. As of my last update, the Prime Minister of India is Narendra Modi. Please note that this information may have changed. So I recommend checking the latest news for the most up-to-date information. Right. So why? So finally, it has given the answer saying Narendra Modi, but also it is telling that last update means last the model was training. That time Narendra Modi was the PM. After the events, whatever happened, LLM may not be aware. So that's why it is giving extra warning, saying that this information, it might have changed because we know that every LLM will be having a knowledge cutoff, right? In the RAG sessions we have discussed what is knowledge cutoff, right? So since LLM doesn't aware of whatever events happens in the after knowledge cutoff, so that is replying as note that this information may have changed. All right. So basic funda you understood, right? So what we are doing here, we are maintaining all our previous conversations and we are sending in our prompt as a context to the LLM. In the RAG case, what is happening in RAG case? We are taking users query, right? We are using the retriever. We are retrieving some information from the vector store. Once you got the vector store, you are sending both user query as well as whatever retriever gives you the information as a context, you are sending that as well to the LLM. Now LLM is referring to that context and answering your question. Here also same concept is happening. Now you are sending your previous conversation and whatever question you are asking about your previous interactions. Now LLM has the context, that particular context it has, so that it is replying successfully, right? So with this I hope memory concept is clear. So let us end this memory concept and move to the next concept. Right. Not only this, you can use any external databases, and also you can store all these message histories as well permanently, right? All right. So with this memory is over, and then now we have to move to multi-modality. So what is a multi-modality? Just a moment, guys. All right, guys. So let us discuss about multi-modality. So before moving to multimodality, let me show you this table where I have clearly mentioned what is your use case and what kind of memory approach you can use. So the first use case, simple multi-turn chart, a prototype, or a develop. You are doing something, POC or MVP kind of thing, and you are implementing a simple multi-turn chart. I hope you guys all know what is single turn chart and what is a multi-turn chart. I have already clearly explained, right? So in these cases, better you go with a runnable with message history in memory as a history factory, right? Then a multi-user chatbot with persistence. Example, you are building any Telegram bot or web application based. Then what memory approach you should follow? You should use a runnable with message history plus a backend based history store, or use a Langgraph persistence. See, wantedly I'm not discussing about Langgraph persistence because LangGraph is a separate framework, of course, which is built on Langchain and built from the same team. But our when I start telling LangGraph, it creates unnecessary confusion. So that's why I'm not touching LangGraph persistence. We have several persistence LangGraph persistent classes. We have a PostgreSQL class and all, where you can store your memory permanently, right? And the third use case is long-term conversations or summarizations or token limit concerns. So implement your custom logic, right? We have discussed about this use case. So implement custom history logic, trim old message or summarize past messages, right? So what is trim old message? Let's say you have 100 messages. You no need to maintain all 100 messages. You just trim to up to 10 or up to 5 or up to 20 according to your requirement. That is one use case. The second is summarize past messages. Let's say every 50 messages you send all 50 messages to the LLM and get summarization, and that summary you can store it periodically, right? So that you no need to send all message history as a context to the LLM. Instead, what you can do, uh, you can simply send the summary so that you can save the tokens. You can reduce the latency as well, because your data is getting reduced, right? Now, when you are building a RAG based application, right, with external docs, that time combine your runnable memory with retrieval, and then uh, use conversation memory as well. So I'll share this document so that you can go through this document clearly. So now let's start a multimodality in a lang chain, right? So what is multimodality? As name suggests, as name suggests, multimodality, means the ability to handle multiple data modalities, not just text. So we are in a fifth session, right? We are in a fifth session. If you see from the day one to here, we are interacting with only text. We are only interacting with text. We are passing text and as an input to the LLM, and we are expecting text as the output from the LLM, right? So now what is multimodality means? See, your data may exist in multiple formats, not only in text format, right? It might be in image format, it might be in audio format, it might be in a video format as well, right? So this using a Langchain, you can also pass a multimodal inputs. Using Langchain, you can also pass multimodal inputs. What is multimodal input? Not only text, you can pass image, you can pass audio, you can pass video, right? And then you can expect multimodal output. Multimodal output, assuming LLM supports multimodality. LLM supports multimodality. So most of the proprietary models, they support multimodality, be it a Gemini 2.5 Pro, right? Or it might be Claude, or if you take OpenAI as an example, I think from 4.1 or some 4.1 or 5, I'm not sure, they support multimodality. It means your LLM can understand not only text, it can also understand images, videos, audios, etc. Right. So if you use a 3.5 turbo, if you use OpenAI 3.5 Turbo, it is not a multimodal. So you can only pass a text as an input, and you can expect only text as an output, because since it won't support multimodality, you cannot pass other than text to the model, right? Then, so what is the use of this multimodality, right? What is the use of multimodality? The best use case is, let's say, uh, you have some image and you can upload that image to the LLM and ask a question about that image. Simple example will be, you upload one image, along with image you can write a prompt saying that what is present in this image. Then your LLM try to read your image as well as your text and answers your question. So that is first simple and straight use case. Then second use case would be upload audio or video. Upload any audio file or a video file, and then ask the LLM to summarize this audio or transcribe this audio. It means you are sending input, you are sending audio as an input to the LLM, and then you are expecting text as an output in the case of transcribe, right? In the case of summarize also you are expecting same instead of full transcribe. Again, let's first what will happen, your model will extract the text, and then that text it will try to summarize and will give you uh, a summary of that particular audio or a video, right? So the final point to be proven here is this LLM and Langchain combo can process and mixed data types, not only plain text. That is the overall goal. Overall goal is to tell you that these LLMs supports not only text, they also support images, audios, and videos as well. Now, when you are using multimodality, you have to consider some limitations. You have to consider some limitations. So those limitations I have. What are the first limitation? Not all LLM support multimodal input or output. You need to check model profile, right? So whatever the model you are using to interact with, right? Whatever the model you are using to interact with, uh, every model will have a, if it is a proprietary model, those companies will be releasing this models document, right? So if you go to that particular document, you can easily understands that whether this model supports other than text or not. Then so then obviously when you are uploading your videos and when you are uploading your audios, you need to be careful about privacy and data handling as well, because videos and images will be containing sensitive data as well, right? So you have to take care of that as well. Right. I hope we all understood. We all understand what is a multi-modality. Right. So multimodality is simple. It is the ability to process other than text, be it a image or be it a video or audio. We'll quickly see a simple example of processing, sending the image and text to the LLM and expect a text as an output. Right. So let's go and program that. So memory is done. So what I'll do, I'm going to create a new folder this time. Um, do one thing. Let me close this once. Where is my env file? Env file over here. All right. Let me create a new folder. So new folder, I'm giving a name as a multi-modality. So anyway, we are going to write only a simple program, so no need to worry about it. Let me take a new file, uh, and I'll give this as a image underscore interaction dot ipynb ipynb. All right. So let me take a code node quickly, and since we don't need this, let me close all these things. All right. So I have taken a code node, and then we will start interacting with LLM by passing one image along with the text, right? So let me take a couple of imports first. My first import will be again I'm going to interact with the chart OpenAI models. So that's why I'm going to import from a Langchain underscore OpenAI, right? Import chart OpenAI. And my second import, I just want to import human. I just want to import human message. It is optional. Still, you can import from Langchain. We all know it is messages are exist under Langchain core, right? So go to Langchain underscore core. Sorry. Let me add Langchain underscore core. Inside core, messages are exist. Take that, and from there we need to import human message or what if you want to import AI message also you can import AI message. Since there is a small program, I don't require AI message, so I'm not going to import that. So after these two imports done, then we need to load our environment file, right? Env file. For that, what I need to do, from dot env import load.env, then call this load.env file as well. All right. So sorry, load.env, right? So till now no confusion, everything we are doing as a regular practice. And now I'm going to define a model. Let me take one LLM variable. In this LLM variable, chart OpenAI. So right now I'll not pass any any model. I'll not pass, and we all know that if I don't pass any model, by default it will take 3.5 turbo. See, I know that 3.5 turbo won't support uh, uh, won't process these images. Still, I just want to show you that if you pass a model which doesn't support multimodality, and you ask a question about images or audios or videos, then obviously you are going to get the errors. So I just want to show you that. That's why I'm not taking any model, right? Later I will take a 4.1 mini GPT 4.1 mini model, and then I'll show you how to interact with these things. All right. Now I'm taking one simple message, or you can also take a prompt. It's up to you. Because I'm everything I'm hard coding, that's why I'm not taking prompt. I'm simply taking a human message. Inside human message, in the class one, if you remember, I have written this how to interact with simple model, right? Inside content, I'm passing my question. First question will be inside content. I have to pass objects, and then I have to specify what type of data I am sending. Is it text? Is it message type is text, or message type is image or audio? I need to mention. So in the first case, I'm sending a type as a text type. I'm going to mention it as a text, and then masking my text is going to be uh, let me ask simple thing, what is present in the image. That image also I will attach in the doc. What is present in the image? So this is my simple text. Along with text, I'm also passing one image as well, right? So this time, since I am passing image, I need to declare type as image. Let me declare type as a image, type as a image, and then I have to pass the image URL. So let me pass the URL. So some random URL I have copied from Google. You can also pass any random URL from the Google. I just copied this URL from the Google. So let me show you what is in the image first. Copy it, and then I'm going to execute this particular URL, whatever URL I am passing to the LLM. Right. Now you can see that there is a parrot over here in the green background. So that's it. It's a simple image. All right. So now, so what human message I am sending? I am sending that one image, and I have passed the URL of that image, and also I have sent a text saying that what is present in that particular image. That's it. That's simple. Now you have to call your LLM. LLM, how you will call? Using LLM dot invoke. Invoke is the method. Inside invoke method, you can pass a list of messages. List of messages. Right. All right. So this will give the response. That response, I will store it in a variable called result. There is a spelling mistake. Wait. Yeah. So now I'm going to print that particular result. That's it. A simple. What extra we have done? Extra we are sending one image, right? Other than that, there is nothing extra. Now, let me execute it. As I said earlier, it should give me the error because we are trying to hit the image an LLM which doesn't support multi-modality, right? Let me see. All right. So you can see the error, guys. What is the error? Bad request error. Bad request error. Why this bad request error? Invalid image URL. Right. Expected. So some error you got. Now let me do one thing. Let me change the model. Let me change the model. So what I'll do, I'll take GPT 4.0 mini. GPT 4.1 mini, and then I'm going to hit it. So now you can clearly see that it has given the output. It has given the output. Earlier case, it was not giving the output because a 3.5 turbo is failed to take your image and process it and try to answer your question. But now it got succeed because you are passing the same question to the better model, and this model can understand the images well. And if you see the answer, uh, there are several things are came. Let me show you which model it is first. So anyway, we are passing 0.41 mini there, so we no need to see what model it is. But we let me print only content so that we can get the better visibility, right? So let me hint it enter again. Now you can see that the image shows a vibrant green parrot first on a branch. The background is blurred with shades of green and as well as yellow, suggesting a natural outdoor setting. The parrot has a red beak and so it has clearly able to identify that there is a you know parrot and a blurred background, right? So it is clearly able to understand what is there inside the image. So this is how you have to interact with the LLM uh, with multi modality capability. Now instead of image, uh, let's say you can send some audio file and ask that convert this audio into a text. Then what it will give, it will take audio as an input and will give you text as an output. Similarly, you can send a YouTube video, right? You can send a YouTube video. So since we are discussing multimodality, you can take such kind of project like where you have a videos. Earlier case, we implemented a RAG system using complete PDF files, right? Now, what you can do, you can take the videos, you can transcribe them, and then in the end, finally, you will get some text using text loader. You can, you can load it into vector database, and then using retriever you can give. So basically a multi-modality a RAG based system you can develop, right? All right, guys. So with this, let us end this multi-modality concept, and we will move to the next concept. So don't worry, these codes and all will be available in the GitHub link. So I'll make sure all these codes are uploaded to the GitHub link, right? Let me read a couple of comments. Someone is telling thanks for the recaps. Yeah, thank you. Thanks for your guidance has inspired me to learn more and explore new possibilities with the AI. Glad to know that. And someone is also asking, hello sir, can you provide me the link where I can learn pandas and NumPy for machine learning? So I think you can get it pandas and NumPy lectures in Euron itself. You can just go and explore the channel. You will have pandas and NumPy lectures as well. Right. So with that, let's start our runnables and types of runnables as well as chains in Langchain. Right. All right, guys. So first things first, what are runnables? What are runnables? So everything inside a Langchain ecosystem is a runnable. Everything inside a Langchain ecosystem, you can call it as a runnable. A runnable is a standard abstraction or a building block in Langchain representing a unit of work. A unit of work, which means what? Uh, if you let's say, um, let's take one example. Let's say you are asking a LLM to generate a joke. You are asking a LLM to generate the joke, right? So what will happen? So first you will take the some topic from the user on which topic you want to generate the joke, right? Once you take that, what will happen? You will uh, construct the prompt, right? So uh, making prompt is a unit of work, right? Making prompt is a unit of work. Once you make the prompt, what you will do, this prompt you will pass to LLM, right? LLM will process something and will give you the output. So what will happen? So LLM process is also become one unit of work, correct? And then once you got the output, what you will do, you'll go to string output parser, or you will go to uh, pedantic output parser. Whatever output parser you will call output parser, right? So what output parser will do, it will take some input, process it, and gives the output. So this is called a unit of work, right? Now what runnable will do, runnable interface defines a consistent context. Each runnable can be invoked, batched, streamed, and composed. If you observe from day one, everywhere we are using a single method called invoke, right? So with LLM interaction we are using invoke, with chart prompt template we are using invoke, even with retriever we have used invoke, with vector stores we have used invoke, and with document loader is also we used invoke. So in short, if you want to say, so every unit of work, you know, is implemented from the runnable interface in the in Langchain runnable interface, and this runnable interface gives some set of methods, uniform methods. These methods will be followed by each component, right? So you can see the example with runnables and disparate components, prompts or templates or LLM calls or parsers or custom logic or retrieval, etc., all become first class citizens that can be linked together uniformly, right? So what does this mean? Every unit of work, let's say prompt creation or LLM call or using a parser or using a retriever, whatever it is, every unit of work using a runnable, you can link together. So what is the use of this linking together, right? So one is you can write a clean and robust code. What will happen if you link something? So let me show you. Now, if you see this simple example, what I have one prompt which is responsible for writing a prompt for the poem, right? So here I have a prompt. This is my step one, correct? Then I am passing to the LLM. I am passing to the LLM. This will be my step 2, correct? LLM gives the output. Now what will happen? It will go to string output parser and it will extract the output. So that is my third unit of work. And then that uh, that output I am constructing one more prompt using that output. This is going to be my fourth unit of work. Again, I am telling LLM here, I am constructing a prompt saying that give me the summary of this joke, give me the summary of this joke, or give me the summary of the poem. So what is happening in step 1? I have constructed a prompt saying that generate a poem. Then I pass it to LLM. That now LLM, what it does, LLM takes my input, process it, and gives the poem as an output along with the metadata. Then in step 3, what I am doing, I am passing to output parser. I'm passing to output parser, and my output parser will eliminate all metadata and will give me only content which is present in the LLM output. That is my step 3. Now I am constructing a step 4. In the step 4, what I am doing, whatever the poem has been generated in the LLM, and I am telling that give me the summary of this poem. So that is the prompt I am going to making in step 4. And step 5, that new prompt I am sending to LLM again, and LLM again will process. This will be my step 5, right? This will be my step 5. What will happen in the step 5? It will take the input as a summary prompt, and then it will generate the output. In the end, what it will generate? A summary of the poem it will generate. Then I'm passing this to again my output parser. This will be my sixth step. Again, it will eliminate all metadata and will give me the final output. So you can see that every unit of work, this is one unit of work, this is second, third, four, five, six. There are six steps are involved for generating a poem, uh, and then getting summary of that particular poem, right? Now if you don't use this runnables, if you don't use runnables or chains, you have to individually call, you have to individually call prompt, you have to individually call this LLM by passing this prompt output to this LLM input, and then you have to manually call everything, which leads to huge lines of code. Now by using these runnables, what we can do, that we can make a chain, we can make a chain, so that automatically Langchain will taking care of. If you invoke once full chain, you can invoke once, and then this whatever the output of this step will go to input of this step, and output of this step will go to input of this, and then output of this will go to input of this, and so on. It will continue this chain. In the end you will get the final output. In the end you will get the final output, right? So using runnables, what you can conclude, let me clear this so that you can see the chain clearly. All right. So using runnables, what you can do, you can write a robust code. You can build pipelines. You can build a pipelines because every piece follows the same interface. Langchain can perform batching. You can perform not only invoke method. You can perform batching operations. You can perform streaming operations. You can perform retry operations. Every operation you can perform as well. So in general, what is runnable? Runnable is a task or a operation uh, with standard interface and as well as composability, right? We will see in a program how to implement these runnables. Before that, I need to explain how many types of runnables are there and what do they do, correct? So if you classify runnables, there are two kinds of runnables are available. Two kinds of runnables are available. One runnable is a task specific runnable. One runnable is task specific runnables, and second one is a primitive runnable. Task specific runnable, and then a primitive runnable. So task specific runnable is, what is a task specific runnable duty? Let's say a prompt is a task specific runnable, means it will take some output, it will generate prompt. So only that particular task it will do, so that it will we can say that this is a task specific runnable. Again, LLM call is a task specific runnable. Same, this is also doing same thing. It is taking some input and sending some output, right? This is also particular to that task. So you can say that this is also a task specific runnable. And then string output parser is also a task specific runnable. What it is taking? It is taking complete LLM output. It is eliminating metadata, and then it is giving you the content back, right? This is also, doing some particular task, right? So these are called a task specific, you know, runnables. Second type is primitive runnables. Primitive runnables. So what is primitive runnable? Primitive runnable, these are not perform a task by themselves. Rather, they help combine, sequence, branch, or parallelize the task. So what is happening now? Whatever you are using the connection, right? Whatever using the connection here, these are called primitive runnables. Using primitive runnables, whatever the task specific runnables are there, you can connect them using, you know, these primitive runnables. So this is the simple definition. I know at least now you got some idea what are runnables, what are task specific runnables, and what are primitive runnables. So mostly used primitive runnables are: one is a runnable sequence, runnable parallel, runnable branch, runnable pass through, and runnable lambda. So there are several things. But these are the mostly used, right? So let me explain one by one in detail, and then through detailing program, so that you will get the better idea. So first, what I'll do, I will take a runnable sequence as an example, and then we will make, one chain using a runnable sequence. I think in the day 2 or day 3, we have already seen how to make a simple chain. Uh, Now using runnable sequence, we will make the same chain as well, right? So let me quickly go to the Visual Studio Code, and I'll create a new folder. Let me do one thing. Let me create a new folder, and this folder name I will give chains or runnables, whatever it is you can call. Let me give the chains. All right. So inside chain, let me create a new file, and I will create a runnable sequence chain first. Correct. 1 minute, guys. So now let me do one thing. Uh, let me create. Let me give the file name as a runnable underscore sequence dot ipynb. All right. So let me take a code node. Now let me quickly tell what we are going to do first, and then we will discuss what is runnable sequence, right? So uh, runnable sequence runs a series of runnables one after another, right? So simple definition is what? Sequential composition. Whenever you want to run task specific components in a sequential manner, and means one by one, one by one, one by one. In that case, you have to use a runnable sequence. So what runnable sequence does, output of one becomes input to the next, equivalent to the a classical equivalent to the classical chain. So if you clearly see here, what we have a six different steps, right? And we have a six different steps. Step 1, 2, 3, 4, 5, 6. So using, if you see, observe clearly, what we are doing, we are constructing a prompt, and then we are passing prompt to LLM, and then we are generating a poem, and then we are extracting the poem. Then we are preparing prompt to, right? In the prompt 2, it will be having this poem, whatever llm generated, and we are asking give me summary of this poem, and then it will go to llm, and llm will give the output. LLM will give the output. The string output parser will take the LLM's output, eliminates the metadata, and then give you the content finally. So in the step 1 to step 6, all these things should happen sequentially. All these things should happen sequentially. Why I am telling sequentially? See, if you run poem call first, immediately if you run this LLM, it will not it will not work out, because you are dependent on this string output parser's output. This will give you the poem. Once this gives the poem, then you have to ask the another LLM to generate the summary of that particular poem, right? So in the nutshell, what you can say that, or in the short, what you can say that, using runnable sequence, if you use runnable sequence here, what will happen? This output will become input to 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 this, and this output will become to input to this, and then you will get the final output, and then you will get the final output. So all the steps are executed sequentially, one after another, one after another, one after another. This is what sequential execution, right? One after another. If it is parallel, means independently tasks has been executed, that is called parallel, right? But here we are not executing any task parallelly, we are executing every task sequentially, right? So now, so this is the program we are going to write now. So we are constructing this particular chain using a runnable a sequence, right? So I hope my point is clear, so that we can go to the Visual Studio Code and start writing the code. Now take first three steps to avoid the confusion, then we'll take the next three steps, right? So in the first three steps, what I need one prompt, I need one LLM, and I need one output parser. So let us go and declare these things first, right? So in the starting, let us import whatever is needed. Import, from Langchain underscore OpenAI, you need to import one LLM, correct? Chart OpenAI. Sorry, this is from that side is going here. So from Langchain underscore OpenAI, import chart OpenAI, and we need prompt. So for that, what we need from Langchain, prompts are available inside Langchain underscore core dot prompts, correct? And then import prompt template. You can also import chart prompt template. It is up to you what kind of template you want to use, right? And then we need one parser. So where parsers will be available inside Langchain underscore core dot output parsers. So let me go there. From Langchain underscore core dot output parsers, import which output parser we are expecting. We are expecting a string output parser, right? So if you want pydantic, you can take pydantic output parser, but we need a simple string to be processed. That's why we are going to import a string output parser, right? Now since we are using a runnable sequence, we need to import a runnable sequence as well, correct? Let me import that quickly from Langchain. This is also a core part of Langchain, so all core part of Langchains will be available under Langchain underscore core, correct? So let me go to Langchain underscore core, and then if you do dot, you can see the core components embedding chart loaders, chart histories, messages, output parsers, all these are available. Even runnables, retrievers, all are available inside your Langchain underscore core. Now let me take runnables. Once you take runnables, you can import a runnable sequence. You can import runnable sequence, correct? Let me write. You can see that there are several sequences are available. There are several runnables are available. In that we are going to import a runnable sequence. So we are going to discuss five runnables. Mostly all are the same. If you are comfortable with these five runnables, You can also use any runnable whatever you want. Now, one last step we need to do from .env, we need to import a load env. Correct? Load.env. Once this is done, just use that function and load all our API keys. Correct. Now we have successfully done. Now, what we have to do? We have to construct a prompt which is which is responsible for constructing a prompt to generate a poem, and that will go to LLM, right? So let me quickly take one prompt saying that poem underscore, sorry, spelling mistake, poem underscore prompt, I'm going to call it. Correct. So what I'll do here, I'll take a prompt template. You know that a prompt template, using a form template, uh, dot form template, I think till now we haven't used, but this time I'm going to introduce a new method called dot form, template, dot form template. So this is the new method I'm going to introduce. Earlier we were using prompt template in different way, where we are just passing template and as well as input variable. Right now we are seeing a new way of declaring a prompt template. Now what I have to do, I just need to pass one I just need to pass one a string over here. So my string would be write a program, write a poem, write a short poem in 4 lines about topic. If you want, you can increase, let me say 8 lines or 7 lines, 6 lines, whatever lines you want. So I have taken prompt template dot form template. Earlier we were declaring template and input variables. That is the one way of declaring prompt template, and this is another way of declaring prompt template. You can use previously how we are using a same thing also you can use as well. Right? There is no issue at all now. So we have successfully declared a prompt variable, and we need to declare one model. Now let me declare an LLM with a chart open AI. Chart open AI. So I am taking default model, so I no need to pass any model because I am not using any multi-modality. So 3.5 turbo will be good enough to generate a poem. Now, so prompt is done, LLM is done. Now we need a parser. So let me take a parser. Parser is a string output parser. So let me declare that parser as well. That parser as well. Now let me quickly show you without without using a runnable sequence or chain, we are going to achieve the task. Then using runnable sequence, we are going to achieve the same task as well. Correct. Now, what I need to construct a poem underscore prompt dot uh, what you can do, you can use invoke method. Correct. Invoke method. Inside invoke method, you have to pass a dictionary. In the dictionary, what is the variable name? Variable name is a topic. So same, take topic and then pass topic as an AI. So whatever the topic you want, you can simply pass. There is no need of you have to pass only AI. So in this case, I am passing AI. You can pass any topic. Now, so this will give me the final underscore prompt. This is going to give me the final prompt. Right. Now, what I need to do? I need to invoke my LLM by passing this final prompt. Correct. Now, let me do one thing. Let me invoke my model LLM dot invoke and then pass final prompt. All right. This will give me the result. RE. Let me store it in a result variable. Now my result is having this LLM's output, which also having all metadata and all. So now I want to call a string output parser and then invoke that by passing a result. So now I'll take one more variable called final result is equals to final underscore result is equals to I have to take a parser dot same. Since everything is runnable, everything supports invoke method. Invoke, and then you have to pass your input string, right? So in my case it is going to be a result, and then I'm passing my final result, what it has to give in the end. Final underscore result. So what we are in short, what we are doing, we have taken a prompt, we have taken LLM, we have taken parser. Using invoke method, we constructed prompt. Using invoke method, we invoked model. Using invoke method, we are invoking parser as well. In the end, final result we are going to print. So this should give me a short poem in a 8 lines of 8 lines. It should generate a poem, correct? So let me generate my select my virtual environment, and then it will start executing. Yeah, it started executing. All right, guys. So you can see that a poem has been generated in 8 lines, right? So just read the poem. Now, what we will do, we will try to achieve a same thing using a runnable sequence, right? So till now we are not used runnable sequence. We are, we are invoking individually every task, but using runnable sequence, you know, you can combine all these tasks. One task output, if you observe carefully, this is the prompts output, and it is going to input as a LLM. And LLM gives the output, and that output is going a input as parser, and parser will give the final result. So where you are, passing everything manually, taking output of from one component and passing to another component, and taking output and passing to another component. Now, by using runnable sequence, we will eliminate all these things. Now let me comment these 3 lines for now. Let me comment it. Now let me take, yeah, since we don't have final result variable, let me comment this variable as well. All right. So now what I'll do, I'll take a runnable sequence. Let me call that as a chain. One variable I have taken, which is called chain, and I'm taking this chain. I'm declaring one runnable sequence class. Right, inside class, what I have to do, you can see over here, you have to pass steps in a sequential manner. So what is my first step? My first step would be invoking the prompt, so that I'm going to pass this poem prompt, comma. My second step is invoking LLM. You can see that, right? We are invoking first prompt. That's why I'm passing that first prompt here. In the second, I'm invoking LLM. So I have to pass my LLM over here. Copy it, up, paste it. And then third step, I'm going to use my parser. I'm invoking my parser, so that let me take this parser and pass it inside runnable sequence. Now what will happen? Now runnable sequence is taking care of, you know, passing this output to this LLM, this output to this parser, and final output it will give. So instead of individually invoking everything, now you can start invoking this chain as well, correct? So let me invoke chain dot invoke, chain dot invoke. If you observe closely, when invoking the prompt, we are passing a dictionary, and then we need to send a variable value called topic. The same thing we need to paste it over here. Now this time, instead of AI, let me give a machine learning. All right, guys. So nothing we have done. We have taken a runnable sequence, and we have mentioned, uh, you know, individual step. What is the first step? What is the second step? What is the third step? Then runnable sequence will take care of, passing this output to this input, this output to this input. Now the final result will be stored in a variable. Let me call it as a result. Let me call it as a result. Now print the result. So what it should give? It should give a poem in 8 lines. So same, but this time instead of AI, it should give on machine learning. Let me quickly execute it. All right, guys. Now you can see that 8 lines of a poem it has been generated successfully. Right. Now let us go to our runnable sequence chain. So we have successfully implemented this first chain. Now what we need the second chain as well. We need the second chain as well. So then only this will become complete chain, right? So then this will become complete chain. We have done till now half of the chain. Now let's implement second half of the chain as well. So for that, if you observe carefully what I need a second prompt. I need second prompt, and this prompt is having dependency of output of the string first parses output, correct? So here poem is there. This poem has to go to this prompt, correct? So how we will pass that? Let me declare a new prompt now. Let me go and I will call this time summary underscore prompt. Summary underscore prompt. So let me copy paste all these things because anyway we are going to declare only a prompt, right? But this time I will declare some random variable. Let me call this variable as a text, and my prompt is going to be summarize the following summarize the following a poem in 1 line. So now I'm generating 8 lines of poem and I'm asking that summarize this poem in 1 line, and I'm passing that particular poem. Poem is poem is this poem, correct? So now what will happen? I am extending my chain, correct? Now this string parses output will go as a text input to this summary prompt, right? Now what I have to do? Let me extend that using summary underscore prompt. Summary underscore prompt. All right, guys, able to understand, right? So first I will invoke using machine learning. I'll invoke using machine learning, right? Now what will happen? It will construct the prompt, and prompt will go to LLM, and LLM output will go to parser. Now parser is having this 8 lines of poem. Now what will happen? It will generate a new summary prompt where it will having that summarize the following poem in 1 line, and poem is whatever parser is holding, that poem will become input to this text variable, right? Now we are extending this sequential chain, correct? Now we have made a second prompt successfully. We have made second prompt successfully. Now what we need? Again we need to pass this prompt to LLM, and then LLM will give output that will go to string output parser. Now here you may get the question, can I use the same LLM or do I need to use a different model, right? So it's up to you. Either you can use the same LLM model, or I can take a new model. Let me call a variable called model, and this time I'm going to take same chart OpenAI, or I can also take Gemini. Let me do one thing. For simply for better understanding, now I'll do one thing. Let me take same LLM first, and then I will take Gemini model and I will show you the same program, right? So let me comment it. Yeah, so same LLM you can take, or you can use a different LLM from the different provider as well, or you can also use your open source LLM. It's up to you, right? Now this prompt will go to again one more LLM. Now LLM will process, LLM will get the instruction this time, summarize the following poem in 1 line, and the poem is 8 lines of poem. Now it will summarize, it will generate the output. Now this output again, what it has to go? It has to go to the output parser. So we will get the final output, correct? Now, so again, same parser I need to take. Yeah, you can take same parser, because again, in the end, it is parser's job is what? It is taking LLM's output, and then it'll give you the eliminate the metadata and then give the final output, right? So we are doing the same thing. So when we are doing the same thing here and here, then we can also use same parser, right? So let me add same parser over here. Now this output goes to LLM input, goes to parser input, goes to summary prompt input, goes to LLM input, and then goes to parser input. And finally, whatever the when you are invoking this final chain, when you are invoking this chain, and final output will store it into result, and that result we are going to print. So efficiently now, final output is what? Summarization of the poem. This time we are not going to get the poem, we are getting summary of the poem, right? Now this should not be 8 lines of a poem, because we have clearly mentioned that we need only one line of poem. So let me execute and show you the output. Let me execute it. Now you can see that within a one line you got the output. Within a one line you got the output. What is the summary? A machine learning uses algorithms to uncover patterns and predict something something. It has given whatever the poem has been generated by the first LLM. Now your question is, can I use same LLM or can I use different LLM? It's up to you. Now what I'll do, let me create a new model called a model variable using let me do one thing, Gemini model, or let me take Gemini model from Langchain underscore Google Gen AI, because we are going to use Gemini model. Import Google, import Google generative AI. We are not sorry, chart Google generative AI. In case of OpenAI, it is chart OpenAI. In case of Gemini, it is chart Google generative AI. So let me declare this model quickly. So let me do one thing. Let me copy from our previous program. We need a model name also, right? So I think inside Lang LLM, we might be having a Gemini also. All right. So model Gemini 2.5 plus is there. Let me copy this line and then go back, paste it. All right. So I have taken model. Then instead of this LLM, what I need to do, I need to pass Google model. Now let me pass the model. Right. So what I'm trying to prove is you no need to use same LLM in uh, sequential chain. Whatever the model you want to change, you can change. So let me run it. I'm not sure my Gemini key is correct or not. If it is correct, we will get the output. Otherwise, we will get the API key error. Right. All right. So it has given API key has been expired. Let me do one thing. Let me quickly go to Google AI Studio. You all know, right? In that session one, I have already showed how to generate key. I think it is free. You guys can go and try. Just Google AI Studio. Or let me do one thing. Let me create. It is asking login and all. So I have already account logged in. Let me do one thing. In Chrome, I have same account. Google AI Studio. I don't know. This is also asking login. So do one thing, guys. Let me quickly log in. Yeah, I have already logged in. Just go to get API key section. You can see the API keys over here. If you want to create new API key, simply click on create new API key. Then let me add lang tutorial text something. Then select one for project. I'm selecting default project. Then create key. It will generate a new key. All right. So what was my key? Not lang tutorial test. So this is my key. So let me copy this key and then go back to my program uh, in .env. I think I need to replace this key over here. Then save it. Once you save, you need to load your file again. Let me save this file and then load again. If not loaded successfully, I may require to rerun my yeah. No, it is not loading my key, correct key properly. It might be taking from cache. That is the issue. Uh, I need to restart. So I think not to restart. You guys can try this instead of me trying restart again. Time waste, right? So you can restart, right? So that is how you can do it. You can pass any model. It is up to you which model you want to pass. I'm replacing again same with LLM, and then I will try to execute. So basically what will happen, your environment file will be cached and you cannot see this new key every time you load. So that might be the reason. If you restart your Visual Studio Code, then it may work. So simply time wasted. So that's why I'm not restarting. Now I'll let me execute. Now you can see that it has given a summarization. So if you observe carefully, there is a problem here. There is a problem here. What is the problem? Let's say I'm getting only summary. I'm getting only summary. I'm not getting what is the actual poem generated by first LLM. Correct. I'm not getting actual poem generated by the first LLM. So that is generating. It is going to parser and some. It is going to summary prompt and it is going to LLM and it is going to parser. And I am always getting only final output. I am always getting only final output. So this is the problem in sequential chain. So what you can do is using multiple runnables like a runnable parallel and runnable pass through, you can solve, you can solve this, you can solve this problem. uh, since it's already 9:15, I think better we wrap it up for today. So this problem, you remember the problem, right? Problem is we are seeing only a summary, we are not seeing actual poem. So this problem we will going to solve in our next session using runnable, runnable parallel and runnable pass through. We will also discuss in detail what is runnable parallel and what is runnable sequence. I hope runnable sequence is clear at this point. Runnable sequence is used, is runnable sequence is used to combine the individual, individual steps, to combine the individual steps in a sequential manner, in a sequential manner. So with this, guys, let us end for today's session. So then let me go through our syllabus, what we are going to cover tomorrow, and then we will wrap it up over here, right? So let me go to our syllabus. Yeah. So agenda for this is memory we have discussed in detail, multimodality we have discussed in detail. Runnables, we have seen what are runnables and types of runnables also we have seen. A task specific runnables and as well as primitive runnables used to combine these task specific runnables. So we have discussed in detail about runnable sequence. Using runnable sequence, we have also made a chain. One last thing I have forgot, guys, let me show you that as well so that we can wrap it off. You can see that runnable sequence, with for runnable sequence you can also use this using a pipe operator, using pipe operator. So same chain what I can do, right? let me declare a chain variable. Let me comment it. What you can do is, instead of using a runnable sequence, you can use a pipe operator. You can use pipe operator, and then you can combine all these steps, right? So let me show you how to do that. I think already second class or third class we have done it. Still I am going to do it again. Use pipe operator, and then go to LM, use pipe operator, and then parser, use pipe operator. Will go to summary prompt, use pipe operator, then again LLM call, write a LLM, use pipe, and then parser. So you can also declare this runnable sequence chain using a pipe operator in this manner. So at this point, this pipe is shortcut for runnable sequence, and we have this shortcut for only runnable sequence. Unfortunately, we don't have this shortcuts for runnable parallel or runnable branch. Maybe in future they may introduce these shortcuts. Let me quickly run and show you this as well. In the end, we need to get the same output. Right, so you can see that one line output I got. So what we can conclude, you can also use a runnable sequence and combine all tasks together, or use pipe operator and declare your chain. Both does the same thing, right? So this is I want to prove so that runnable sequence will be over, right? Now yeah, tomorrow's agenda is we will continue where we are stopping today. We are going to continue runnable parallel. We are going to see what is runnable pass through, what is runnable lambda, what is runnable branch. Once these runnables are done, you can go to document and you can find several runnables. In the end, concept is some similar. We are seeing enough examples. We cannot cover all runnables in the sessions, right? So you can go through the document. If you want to dig more, you always have that option. Go through the document, and you can find several runnables as well. Now, once that is done, we will go to tools. We are moving towards agent because 60% of our sessions are already covered. Now, leftover is tools, tool calling, and these remaining runnables will be done by tomorrow. In the session 7 and 8, we are going to discuss about agents, actual agents, and then we are going to build one capstone project. So project I am thinking let's build along with a front end and then agent. And also I will show you how your front end HTML page or React maybe HTML page will interact with your agent and get the output, right? So this also I will show you if time is there. uh, um, we can do one more thing. We can host our agent in AWS platform, and then we can invoke using any front-end HTML file. We can interact with our agent. So it is subject to timing, but mostly I will build a front-end HTML page. I will build agent and expose our agent through fast API, and then we can start interacting with our agent through our front end. So this part I'm clear. I'm going to give it in a capstone project. All right, guys. So this is the today's session. I hope everyone enjoyed the session. In case if you enjoyed the session, please hit like button, comment something if you have any doubt. If you need these codes, maybe today or after some time or tomorrow, all these codes from the day one will be available in a GitHub link, which will be available in the description. You can go and find out, right? All right. So with this, we can end the session, guys. Thank you so much for your time. If you have a time, please go and explore Euron platform. If you are a student or if you are a working profession, Euron also Euron also offers you learn and work opportunity, where you can interact with Euron team. You can do some specific specific task in live projects. You can collaborate with the teams. The only thing is, you need to give, you need to have that zeal to, work and learn, and also you should be having some time to interact with the team. This is the only things required, so that you can expose to real time environment, right? They also have, I think I have showed you several times, a consultancy thing they have. If you have any product idea, if you have any college projects, you can interact with the Euron team, so that Euron team will help you building those projects, right? So they have several packages. They have silver package, gold package, diamond package, and for college project, silver package is more than enough. You give your final year project, and they'll you will get industry grade project as a industry grade project. You will get it. If you have someone who is who has a startup and struggling for building all your infrastructure and all, you can contact with the Euron team. They will help you out all your project ideas. That's it, guys. I'm going to end this session now. Thank you so much for your time. We'll meet tomorrow. Whatever pending agenda is there for tomorrow, we are going to discuss.